right. Hello, classes. Happy Friday. Funny story to start off class here. I just recorded this entire thing. Took me about 15 minutes and then hit escape, so it didn't save. So here I am doing it all over again, which is awesome. That's fine. Go ahead and open up your journals to page 307 if you have not already. 307. I initially was going to do numbers 1, 2, and 3, but we're actually going to do 1, 2, and 4 so that you don't have to factor as much. There's one problem that involves factoring, but it's easy factoring. Not so bad. So again, we're on page 307. We're going to do numbers 1, 2, and 4. Okay. Numbers 1 and 2, actually. We learned 3 different theorems yesterday involving segments inside of a circle. The first one involved 2 chords intersecting in a circle. When that occurs, the chords divide each other into these pieces where the product of those pieces are equal to each other. Okay. So let's start with this chord here. All right, what are the 2 pieces of that chord? So here's the intersection point. What are the 2 pieces? Hopefully you're thinking 6 and 5. So we start off by taking 6 times 5. All right. Then we go to our other chord. And what are our 2 pieces of the green chord? Okay, x and x plus 1. So we take x times x plus 1. On the left, 6 times 5 is 30. And on the right, hopefully you're thinking distribute. Now, whenever you see a binomial, something with 2 terms, you should always put it in parentheses, because if you don't, then a lot of times you forget to distribute your x through or distribute whatever through. So anytime you see a binomial like this x plus 1, you should always put it in parentheses so that you don't forget to distribute. From here, though, we'll go ahead and distribute that x through. X times x is x squared. X times 1 is 1x. Okay. And at this point, there's nothing that combines. I can't cancel anything out. I can't combine anything. So I'm going to have to set this equal to 0 and factor. I'm going to go ahead and subtract my 30 over, and I get 0 equals x squared plus x minus 30. Okay, we will have to factor this one, but it's not so bad. The leading coefficient is 1. So remember, when you factor, you're trying to find 2 numbers that multiply to negative 30 and add to 1, because there's really an imaginary 1 in front of that x. So they want to add to multiply to negative 30 and add to 1. So let's think about our factors of 30. Okay, 1 and 30, 2 and 15, 3 and 10, and 5 and 6. Those are my only factors. So I have to think to myself, which 2 numbers can I combine and get a sum of 1? Is there a way to combine 1 and 30 and get a sum of 1? No, too big of a difference. 2 and 15? Nope. 3 and 10? Nope. 5 and 6. Can you combine 5 and 6 and somehow get 1? Yes. If which number is negative? Hopefully you're thinking the 5 needs to be negative. So we'll have factors here of x plus 6 and x minus 5. Because then 6 times negative 5 will give you negative 30. 6x minus 5x will give you 1x. To get my answers, I take each factor and set it equal to 0. Let you get caught up here if you're not caught up already. On the left, to get x by itself, minus 6 from both sides, we get x is negative 6. And on the right, add 5, we get x is 5. Now, one of those answers does not make sense. Okay? Hopefully you're thinking the negative 6. You can't have a length that's negative. You either have 0 length or you have a positive length. So x being negative 6 doesn't make any sense within this problem. So our only answer here could possibly be is 5. Okay. All right, let's do that same thing on the next problem, number 2. We will not have to factor in this one. Let's look at this chord first. Okay, what are the 2 pieces of that chord? 10 and 7x. So we take 10 times 7x, set it equal to, go to the next chord, 2 pieces of the blue chord, 15 and 5x minus 2. Again, you should always put your binomials in parentheses so that you don't forget to distribute. On the left, 10 times 7x is 70x. On the right, distribute that 15 through. 15 times 5 is 75x. Minus 15 times 2 is 30. Two-step equation from here. Minus 75x from both sides. I get negative 5x equals, don't forget, that negative comes down with the 30. Negative 30. Divide by negative 5. And I get x equals 6. So that was kind of big idea number 1 yesterday. When you have 2 chords crossing inside the circle, they divide each other into pieces where the products are equal to each other. Okay. Let's move on to number 4. We're going to skip number 3. We learned 2 other theorems yesterday. The second one we learned was when 2 secants intersect. And the third one we learned was when a tangent segment and a secant segment intersect. And that's the one we're going to deal with here in number 4. That theorem said that the tangent piece squared equals the outside piece of the secant times the entire secant. So tangent squared equals outside piece times the whole thing. So first of all, you have to identify which of those up there is the tangent piece. Now remember, a tangent is something that intersects the circle at one point. So it is strictly on the outside of the circle and does not go through. So which of those up there would be the tangent segment, the piece that's strictly on the outside and just touches the edge of the circle? That would be your x plus 1. So we start with x plus 1 squared. And we set it equal to. And then we go to our secant segment. It's the outside piece times the entire thing. So on our secant segment, which one of those is the outside piece? So outside the circle. That would be x minus 1. Times, not times 5, it's times the entire thing. So the entire thing here, we normally just add those 2 pieces together. So if you add x minus 1 and 5, as I'm doing down here in the corner, add your like terms, negative 1 plus 5, you get x plus 4. So that would be your entire segment here, x plus 4. So one more time, your tangent piece squared equals, on the secant, the outside piece, which is the x minus 1, times the entire side, which if you add those together, you get x plus 4. Now, x plus 1 squared, anything squared, is something times itself. So I'm going to go ahead and rewrite that. Okay. We got all kinds of binomials happening here. We are going to have to FOIL on both sides, or box method on both sides, but you'll see some cancellations happen, so we still won't have to factor in the end. Let's go ahead and FOIL on the left side. X times x is x squared. X times 1 is 1x. X times 1 is 1x. And 1 times 1 is 1. All I did was FOIL out that x plus 1 squared. On the right side, x times x is x squared. X times 4 is 4x. Negative 1 times x is negative 1x. Negative 1 times 4 is negative 4. Let's go ahead and combine our like terms here. So we get x squared, 1 plus 1 is 2x. And on the right side, x squared, 4 plus negative 1 is 3x. And here's what we're looking at. Okay, from here, I see something on both sides of the equal sign that is 100% identical. Something, one on each side of the equal sign that is 100% identical. And that is our x squareds. If we have one on both sides, we can subtract them away. They cancel out. And we're just left with 2x plus 1 equals 3x minus 4. Whew! No factoring. Yay! From here, we're going to move our x's to one side, move our constants to the other side. I like to keep my x positive when I can, so I'm going to go ahead and subtract the 2x over. And I get 1 equals, 1 equals 3 minus 2 is just x minus 4. So then finally, to get x by itself, I add 4 to both sides and end up with x equals 5. Let you guys look at that for a second. Get caught up if you're not caught up. Okay, from here, you can go ahead and put your journals away. The first thing you need to take care of, if you did not do your book assignment last night like you were supposed to for homework, that's what you need to do first. So our homework assignment last night was page 573, I believe. Let me double check. Yep, 573, 3 through 14 all. You all had to do at least one problem before leaving yesterday, so you should have it at least started. If you weren't here yesterday, you need to go to the back, get a note sheet from the Thursday box, and copy over the notes from somebody. After you've done the notes and the book assignment and whatnot, and you're ready for your worksheet, there are some worksheets up at the front. They say 10.5, but it's because they're from last year's book. They're really the 10.6 information. It's just last year it was called a different section. So they say 10.5, but they're actually the 10.6 worksheet. There's no decimals on your worksheet whatsoever. And you don't have to factor once on the worksheet. I think there's one problem on your book assignment where you have to factor, but not on the worksheet. So it should be pretty straightforward. There's 13 problems, but a lot of them are pretty quick. So again, book assignment comes first. Finish that up. Then you'll have the worksheet after that. If you're giving blood today, I'll be down in the gym, so I'll see you. But if not, I will see you Monday. Have an awesome weekend. Worksheets will be due Monday. And test is next Thursday, coming up pretty quickly. Just keep that in mind. You can get caught up this weekend. All right, awesome. You guys have a great weekend, and I will see you Monday.